Welcome to American Medicine Today. We're here at USF in the CART area alongside Dr. Redwan El-Qasimi. Why don't you go ahead and explain what CART stands for?
CART stands for Center for Assistive, Rehabilitation and Robotics Technologies. Most of the technology and research that we do is basically to assist people with disabilities in their daily activities, and we use robotics technologies to assist them, do these activities.
So here at the USF Center for Assistive Rehabilitation and Robotics Technologies laboratory, they have something called Baxter, which is a pretty cool machine they put together. Helps assist people with disabilities in their everyday living using robotics that were developed by the students here at the University of South Florida.
Baxter is actually two different robots. Baxter is a two-armed platform mounted on PowerBot, hence Baxter.
The good thing is we have added a lot of sensors into it, the sensors that are already there and the sensors that we've added. Now we can do a lot of things that can really help people with disabilities to work on this and have it an assistant in the house or in the hospital.
By speaking into your Android device,
Baxter, get me the red object.
You can have Baxter help you around the house by going and grabbing you a book to read or bringing you a bottle of water.
So we have programmed an Android phone to interface with this. So from your phone, wherever you're in the room, you can say, Baxter, go get me this book, and state the title and the author of the book. It goes to the bookshelf, it scans all the books, and then it looks for the title that matches what you said and the author that matches what you said, picks it up, and then looks for you all around the room until it finds you, and then goes to you and gives you that book.
Now, is that something that you have to program in? Because obviously the robot can't read on his own, and he doesn't know authors and titles.
We use Connect to navigate through the room and take pictures and videos of everything that surrounds it, avoid obstacles, and also, once we have the bookshelf in the view of this, it starts looking at each one of the book and the title and convert the picture into a string of text that it can compare against what you said. And then it picks it up and then goes and finds you and gives you that book.
Okay, now you said you've correlated some sort of Android type software in here.
Right.
We know what drawbacks something like Siri has. Does it always understand?
That's a very good question. No, the answer is no. So it has to be a clear voice that would be trained on, and it will recognize this and convert it into a string of words that it would mean something to Baxter.
The videos were incredible with Baxter, but how long of a relay is it from the time that you send the information you need till it's able to do the task you asked?
Assuming there's no obstacles, usually it takes, with the speed that we set it up with, it takes maybe about a couple of minutes to get you what you need. If there are obstacles, of course, it has to navigate around the obstacles. If there's no way to navigate around it, it will come back and say, I'm sorry, I can't get it for you.
And so you taught Baxter how to play board games. Tell us about how you did that and how good Baxter is. Could he beat me?
It can beat you.
Yeah?
It bet me, of course. So what we do is, we have the Connect again here, the sensor, and it draws a map of the possibilities that you would be doing this to win. So you put one of the chips there of your color, it recognizes it, and then it tries to see what are the next round possibilities, the second round possibilities, up to the fourth round of possibilities.
It can think 4 steps ahead.
4 steps ahead.
Wow.
And then if you set it on 4 steps ahead, most likely it's going to beat you. If you set it on the 1 step ahead, you can beat it quite easily.
He does this with visual recognition of the colors. Now, did you take it easy on the school children, or did you ramp it right up to 4 and show them how impressive your Baxter is?
You'll be surprised how school children are doing. They were picking the one of the toughest levels, and they're getting very close, and some of them are beating it. They're doing much better than I am doing.
And you made it.
Baxter can also mimic a user's motion using the Connect sensor, and it can be mimicked through the Ethernet, which can actually be done across the world. I got a chance to test out Baxter. I did find it difficult to use. However, once I got past that initial awkwardness, it was amazing that I could actually pick up a bottle and hand it to Ethan through a robot that could technically be accessed from across the world. This takes much more talent than I apparently have, much more coordination.
If you move your body, there you go. Yeah!
Oh!
Once the motions get minute enough, maybe surgeries can be performed. Possibly you could build things on Mars using a robot with a human operator on Earth. And it makes a lot of sense for things like bomb squad or other dangerous occupations where you could have a robot go in place of a human being, yet be controlled by that human being in order to defuse a bomb or a dangerous object.
Now, accuracy is a very important thing here. So if you're doing a surgery that's very fine, you're going through some organs, and so accuracy would be very crucial on this aspect. We are not there yet for the accuracy side, but for general purpose, it's right here.
He was great at sorting out between plastics and glass when it came to recycling.
Baxter actually can use the feel of an object in order to sort them.
If it's solid and it feels that it's glass, we have force sensors here, then it knows that this is glass and it puts it in the glass jar.
For instance, plastic squeezes more than glass or metal, and therefore Baxter can detect when it's plastic rather than glass or metal.
It knows it's plastic and so forth. So it can sort things out based on the feel of what the object is.
A lot of the people that are talking about raising the minimum wage, and then people on the other side are saying, well, if you do that, you'll be replaced by robots.
There it is.
There's your competition.
Actually, no, I disagree. All what you're doing is you're moving the low-paying jobs and getting more demand into the high-paying jobs. So you're saying, if this is your job, please go get an education, then you can service this robot, you can program this robot, you can do this robot. So we're not taking your job away, but we're encouraging you to catch up.
So Baxter is bettering society.
There you go.
I like that.
Right. So you're taking jobs away from one sector and putting it in another sector.
So why don't you tell us a little bit about the Android chair?
So the Android chair idea started with a faculty in the visual and performing arts.
They wanted to have some sort of platform where a person with disabilities could dance with an able-bodied person, but their hands needed to be free.
So what we did here, we did the first prototype, we converted the seat itself to the joystick, so basically they can move their body, and then it will move the wheelchair. And then we thought, they need a lot of trunk strength to move this. So the next thing we did is we used an Android phone, which has already sensors and accelerometers that we can use. So they can put this on any of their, pockets or anywhere else. And then as they move, it will take this data and wirelessly connect it to the chair. And the chair will move accordingly.
So you're programming the phone to control this chair, correct? Yes. You're connecting it to the chair right now, to the phone, via Bluetooth.
I'm going to move you forward a little bit so that you're not in the middle.
Okay. Uh-oh. Where are we going?
So keep it level.
Oh, there we go. Left. Whoa. Don't want to run into that. Whoa.
And if anything goes wrong, just tap it, it will stop.
It's terrifying knowing that there's millions of dollars worth of equipment around me and I'm just running amok on this chair that I don't know how to control. I'm getting dizzy on this thing. Whoa. Yeah, it was pretty interesting. I thought, why not give it a try? And in fact, they actually use a hat with a little recess in it where they put the Android inside the hat, and then using the motion of your head, you control the motion of the chair.
This will be really nice hair.
My super coiffed hair. Can we get it to like moonwalk? I feel like Michael Jackson with this fedora.
And if you want to put your hand on the red button.
Just in case. That's the panic button.
Yes. It should be
I
started.
can go? Okay, here we go. Oh, I'm gonna run into that chair. Let's go this way. If you lean your head forward, the chair will move forward. Lean your head to the side, the chair will turn to the side.
But for safety, we make it, we reduce that amount of amplitude of motion.
Safety schmafety. So why don't you tell us a little bit about this WMRA?
So WMRA stands for Wheelchair Mounted Robotic Arm. What this does is basically we're talking about people who are on wheelchairs. They're already confined there. What happens is oftentimes they have difficult time and hard time to reach out to things. If something falls off to the ground, they can't even retrieve it. So a wheelchair on their, or a robotic arm on the wheelchair would really help them in their activities of daily living. So what we did is we built a robotic arm from the ground up here at USF. And we have programmed it to go seamlessly with the wheelchair. So basically the wheelchair and arm are one body together. So for example, a human goes to open the door, you just walk, you never think of your body separate from your arm.
Correct.
Similar thing there. Now we have the wheelchair and the arm as one person. And as you move, you can control both of them seamlessly.
Right now, it's controlled by a human being using a stylus. In the future, they're going to use an EEG cap, which essentially will be controlling the robotic arm using thoughts and electrical stimulation from the person's brain.
One of the things that we really pioneered in is the brain-computer interface, where a person with complete paralysis, they cannot move any muscle. They can put this electrode cap in their brain, and then we can pick up the signal and have them think. And the way they think, the robot arm goes and does whatever they want to do.
It takes about 30 minutes for the device to map your brain so it understands what you need it to do.
So it's obviously pretty simple in the research and development phase right now, but once the wheelchair-mounted robotic arm is actually ready for mass production and consumption, imagine a paraplegic being able to strap one of those to a chair itself and use the electric cap, which uses its thoughts to be able to perform tasks for the paraplegic. So it immediately expands the range of mobility that a paraplegic person would have.
What we require the person to be cognitively well, so that they can concentrate on what they want to do. And we get this signal and we can analyze it with the stimulus that we have, and then make the robot do what they want to do based on the stimulus that we provide them.
If you're focusing so much on the end-all use and trying to get the machine to move, that's got to be taxing on the brain.
It is. Actually, what we found with studying this with the subjects with and without disabilities, what we found out is that after 30 minutes of cognitive load that we have, we have 100% accuracy, and then afterwards it goes down to very low rates because simply they cannot concentrate anymore. And this requires a lot of concentration.
So doctor, if people wanted to get involved and help with your research, how do they do so?
They can go to our website, www.cart.usf.edu.
Well, it's very important research and we enjoyed seeing it.
Yes.
So thank you for having us.
No problem.
Thank
Thank you very
you.
much.